Okay. Okay, so let's start. So where exactly do you want us to actually talk about this area so that we don't overflow too much here and then we'll move on? Is there any particular area now that you want us to touch?
Not really, no.
Okay, so homologous series, there's no long story there. At this point, just let the student know the definition of homologous series and also the characteristics of properties. Then homologous series by definition is a family of organic compounds. Organic compounds which follows a regular structural pattern in which each successive member differs by a CH2 or a relative molecular mass of 14. The family of organic compounds in which each successive member differs by a CH2 or a relative molecular mass of 14. How did they arrive at that 14? The relative molecular mass of carbon is always 12. So if carbon is 12, hydrogen is 1, 1 times 2, all together should give me 14. So that's how they got about this 14. Each successive member differs by relative molecular mass of 14 grams per mole. That is what homologous series is all about. That is the definition of homologous series. Then it is also important to know, because we said it is a family of organic compounds. So that means we have examples of homologous series to be such as your alkanes. You have alkenes, alkynes, alkyls, alkanols, alkanoic acids, or say carboxylic acids. Other examples also, we also have the aldehydes. But these are common ones, common examples under homologous series. Then each of these series has their general molecular formula, such as the alkane is CnH2n plus 2, alkenes CnH2n, alkynes CnH2n minus 2, alkyne CnH2n plus 1, alkanols CnH2n plus 1, OH. Mind you, this alkyne can also be written as R. Then alkanoic acid is CnH2n plus 1 COOH, or we say RCOOH, or even sometimes it as HCOOH, that is for methanoic acid in such a situation like that. Any question? Are you with me, Madam Esther?
Yes, I'm with you.
Okay. These are examples of homologous and then their general molecular formula. It is important to let them know what are properties of homologous series. The properties of homologous series are not far-fetched. One is that all members of an homologous series has a general molecular formula. So like that of our case is this, these are the general molecular formula. Then all members of an homologous series can be prepared by similar method. So that is why when we are treating, for example, now under alkanes alone, we have the first 10 members of alkanes. If we now begin to treat the first 10 members, let's say, for example, say methane, you look at chemical properties, physical properties, preparation. We'll now go to ethane and the rest. I bet you before the student will finish secondary school, they are still on one of the homologous series. Hence, we said they are prepared by similar methods. So when we are talking about any of these homologous series, we just use one example and use it to generalize others. And just like when inspectors come to inspect now, maybe doing inspection, they walk into a class and they just pick a child's notes. And luckily enough, it happens to be the child that they used to copy notes. They will just generalize it and don't use to give notes. Or the time it was not marked, they will say that the teacher don't use to mark notes because it's what we call random sampling and use it to generalize everything. So the same thing on the archive, we only treat one member and use it to generalize the rest because one is applicable to all. If we say that they all have a general molecular formula, they can be prepared by similar method. Then another chemical properties of it, or another properties of them is that they all have similar chemical properties. They have similar chemical properties, like the alkenes, their properties is similar. So methane has similar properties to butane and the rest. Then their physical properties varies slightly. People now they don't have the same physical properties. It varies slightly as the number of carbon atom increases. That is another thing to note about the homologous series. Then also let the student know another is that each successive member of an homologous series differs by what? Can you help me, please?
Probably CH2 control.
Differs by a CH2. It is not only it's mostly applicable to all. If you doubt, let's see, for example, we have alkanes. Plus 2, CN, A to N, A to N minus 2, N, 2, Now, for alkanes, the first member is 1 carbon atom. So that will be C. 2 times 1 will give me 2 plus 2, that's 4. CH4. We don't need to write C1H4. Don't let the student know it is CH4. And this CH4 is called methane. Then the next one where my N is 2 will be C2 because N is 2. 2 times 2 will give me 4. 4 plus 2 will give me 6. C2H6. That is ethane. The next one will be C3. C3. 3 times 2, 6. 6 plus 2, 8. C3H8. So if you see it now, as the number of carbon atoms is increasing by 1, hydrogen atom is increasing by 2. So obviously the next one now will be C4H10. Hence we said each successive member differs by a CH. So next member now will be C5 like that. So this is propane. This is butane. Then again, all members of a specific homologous series have the same surface, like in terms of their ending. You can see methane. So they all end with ANE, ANE, ANE. Now let's come to alkenes. I will have continued. The next one will have been C5H10, which is now when you get to this point, let the student just ask them a simple question. A polygon of 5 sides is what?
A pentagon.
A pentagon. So this is called pentane. Just like it learn. Yeah. When you now get to 6 to 15, the polygon is 2 times the hexagon, like saying. Now, on coming to this part, my A is 2. I start with C. The coming back with C3, A, 6. 2, 4.
Okay.
8.
H8.
5.
Okay.
10. This is H12. Same active is applicable here. Carbon is increasing by 1, hydrogen by 2. So that carbon and member differ by C is not only applicable to alkane, it's applicable to all homologous series. Now, this one, first member, I don't have anything like CH2, no, for alkane, because my N starts from 2. And this C2 form is known as ethene, E-N-E. This is propane. It's in. Pentene. Hexene. But however, it's not just like that. So later, by the time we begin to draw it, begin to add some other things to it. But like that. Then this one is then first we start from 2. That will be C2. 2 times 2 will give me 4. 4 minus 2 will give me 2. So C2H4. The next will be C3. 3 times 2, 6 minus 2, 4. This is 2. 3 times 2 H2. Why this is C3H4. Then the next one will be C4. H minus 2. We see again, this will continue. This will now be C5. Add 2 to this. H8. This H10. Just like that. Finally, this is ethyne. Why NE now? Butyne, pentine, hexyne. Any question?
No question.
So next, probably we'll look at. We'll have continued with all this series, but we can't look at all this homologous series. So later on, maybe one of these other days again, by your scheme of work, we are supposed to look at the various homologous series one after the other, alkanes, alkynes, like that. Like what I just did now was just a little overview. Okay. So we look at next is functional group. So let the student know. Sometimes they ask them in theory questions. Define homologous series and functional group. I've given you the definition of homologous series already. Then a functional group is simply defined as group of atoms, molecules, or ions, which gives an organic compound its characteristic chemical properties. That's what a functional group is. It's a group of molecules, atoms, or ions, which gives an organic compound its characteristic chemical properties. So in case they are asked what gives an organic compound its characteristic chemical properties, the answer is the functional group. And so the functional group that is present, for example, now for alkanes, the functional group is that they are saturated hydrocarbons, while alkenes and alkynes are unsaturated hydrocarbons. So that is unsaturated. So this one simply means carbon, single bonds. While this one is double bond, while alkynes is triple bonds. Okay. So it is the functional group which is present in a compound that determines the chemical properties of that compound, not the homologous series that it belongs to. The homologous series is just saying that every member of an homologous series have similar chemical properties, but the properties that is present, or the chemical properties that they possess, is as a result of the functional group that is present in that compound. Any question?
No question.
Okay. So for the alkanols, what is the functional group present in alkanols? You can help. So alkanols has CN, H2N plus 1 OH. That is general molecular formula. So for alkanols, your N starts from 1. So for alkanols, the first member now will be C. That is, I don't need to write my 1, but in case you want to write, you can write it. 2 times 1 will give me 2. 2 plus 1 will give me 3. CH3OH. That is the first member of the alkanol. If you check here now, how many carbon atoms can you see here, madam?
We have just one there.
Because it's just one carbon atom. And all alkanols end with this word, on. Alkanols alkanos are named. Let me just say it now. Alkanos are named by removing the E ending of the alkane and replace it with OL. Remove this E of the alkane and replace it with OL. Say, for example, I have methane. So I'll remove the E ending of methane and add OL. It becomes methanol.
Okay.
So this compound that I wrote here, which is CH3OH, is known as methanol. How do we arrive at it as being methanol? How many carbon atoms? Just one. I always tell my students they can write this number of carbon atoms. Then you can have the parent's name. One carbon atom is called met. Two carbon atom, et. Three carbon atom, prop. Four carbon atom, put. Five carbon atom, pent. 6, X, 7, F, 8, ox, like that. Okay. So if I say only one carbon atom here now, and it's one carbon atom, so it is met, which is methanol.
Okay.
But it is an alkanol because of this functional group, which is the OH. So the functional group present in alkanol is the hydroxyl group, which is this. So, is that okay, madam?
Yes.
Okay. Now, if the second member of this alkanol will be maybe C2H5OH. Do you agree?
Yes.
Okay. It's also very simple. I add one carbon atom, I add two hydrogen. That's the rule. But if you want to check it with the formula, that will be 2, which is this 2. 2 times 2, 4. 4 plus 1, 5. That's this 5 and your OH.
Mm-hmm.
So by name, this is called ethanol. Then the next would have been propanol, butanol, and the rest. Well, by the time we get to IUPAC nomenclature, we'll understand and begin to tweak its names a little bit. That's so for now, let's build up from here. So this is for alkanols. Then again, another group of homologous series is the alkyl group, or we say alkyl. Alkyls has H plus 1 as their general molecular formula, or we can simply say R, capital letter R. For alkyl, alkyls are named by removing, look at it now, by removing the ANE ending of the parent alkane and replacing it with YL. Alkyls are named by removing the ANE of the parent alkane and replacing it with YL. So in case you see it in textbook, that's what it means. And how do I arrive at that? The first member here, which is C1, H 2 times 1. Are you with me? Hello?
Hello.
Okay, so I'm trying to look at the first member of the alkyl using this molecular formula. What will be the first member? The general molecular formula is CnH plus 1 just plus 1. So if my N is 1, that will be 2 times 1, which is 2, plus 1, 3. That is H3 for alkyl, the first member. The second member will be C2, 2 times 2, 4. 4 plus 1, 5. C2H5. Still the same process. You add 1 carbon, you add 2 hydrogen. This will be C3H7. Now, because it's an alkyl group, YL, remember I said it is named by removing the parent, there is the ANE ending of the parent alkane and replacing it with YL. So if, for example, I have CH4, CH4 is called what, madam?
CH4 is nothing.
Methane, good. If CH4 is methane, that means CH3 is what?
Methyl.
Methyl.
Abi?
Methyl.
Mm.
You remove this AND ending and replace it with YL.
Okay.
Then C2H5 is known as ethyl. While C2H6 is ethane. This is 3 carbon atom prop. But it belongs to the alkyl group, so YL or pi.
Okay.
Is it looking confusing, or let me throw more light on it?
No, it's still okay. It's still
Okay.
okay.
So that is for homologous series and their chemical properties and the rest. Then another group of homologous series is a carboxylic acid. Well, I'm not going to IUPAC temperature. Carboxylic acid. Carboxylic acid is CN H2N plus 1 COOH. Let the student know that carboxylic acid, the functional group present is this. This part that I circled is the functional group present. And this part I circled is called the carboxyl group. Carboxyl group. That is the functional group present in all carboxylic acid or in all alkanoic acid. Now, CnH2n, sometimes they can also give it as just RCOOH because this is an alkyl group. We can also be represented as R. Hence, you see it as written as this sometimes.
Okay.
So, if I want to get the first member of this carboxyl group, that will be CH3. I'm sure you understand I got the 3 for. Carbon is 1.
How many?
2 times 1, 2 plus 1, 3. That is CH3. Then with your COOH. So this is. Now, how do I now name this compound? How many carbon atoms is this, madam?
It's one.
Are you sure? Look
No,
at it.
okay. Carbon atoms. Sorry.
A 2 carbon atom. What is it? The parent name?
Okay, that could be
X.
let's wait.
X. So this is ethanoic acid.
Okay.
From the word ethane. So ethanoic acid or ethanoic acid is named by removing the END of the parent alkane and replacing it with oic acid. I remove the ending of the parent alkane and I replace it with oic acid. So I can also still have maybe propanoic acid. Are you with me?
Yes.
Okay, let's do something now. Let's look at how it will be very, very easy. Propanoic acid, prop. How many carbon atom is that?
It's 3.
Okay, 3. Now, because the name is oic acid, that means it belongs to the homologous series known as alkanoic acid, right?
Okay.
So if it belongs to this homologous series of alkanoic acid, which has this as their general molecular formula, which is CN H2N COOH. Are you with me?
Yes.
It is prop. Prop means 3. That means my N is 3. So what will not be the molecular formula?
Well, it will be 3.
Okay. C
7.
C3 H7. Go on.
COOH.
COOH. Okay. But I put it to you that this thing you gave me now is called butanoic acid.
Wrong. Yes. Okay.
Okay. Now, this is how to go about it. Since it is prop, and you agree that prop is a 3 carbon atom, right? Then, if you now want to get the formula, take away 1 from 3. How many do you have left?
2.
2. So that means you are working with this part as your N as 2. So that will not be C2H5COOH.
Oh, okay. Oh, wow.
If you want to draw it out, just so in case for drawing, I will start with the carbon atom first. 2 carbon, 1, 2. Hydrogen is 5. 1, 2, 3, 4, 5. Then this part of the COOH is not like the C, O, O with the H. So this is how it is being drawn. So if I count now, 1, 2, 3. 3 carbon atom, 4 annoic acid. So the functional group is this functional group.
Okay.
Any question?
No, no question.
Your voice is sounding.
So you mean like, sorry, please. So if you have to write it, is the ethanol is the first member?
Yes, the first member of the carboxylic group, the first member is not ethanoic acid, but methanoic acid. So the problem now is, how do I not draw methanoic acid? Because you know that met is 1 carbon atom, right? So for methanoic acid, it is HCOOH. That's how it is written. Okay, so this is methanoic acid, HCOOH. And if you are teaching SS1 or year 1, methanoic acid is used in preparing carbon 2 oxide. That is the dehydration of methanoic acid will give you carbon 2 oxide. That is, if I remove this and this, I'll be left with CO, which is carbon 2 oxide. So this is methanoic acid. Any question?
No, no question.
I'm sure you don't have issues with IUPAC nomenclature. Don't know if I still have time for that. Because this is also SS2 work. But I don't know if you can be able to cover this for the term before the term finish. Are you done with redox reaction in your school?
Almost.
Okay. Yeah, that means you should be entering organic chemistry soon. So
Yeah, that's great.
okay, so IUPAC nomenclature. You don't need to be asking the students what is the meaning of IUPAC, but let them know. I've never seen any question where they ask what is IUPAC. IUPAC simply means International Union of Pure and Applied Chemistry.
Yeah.
That's the meaning of IUPAC. The nomenclature simply means systematic way of naming compound. Nomenclature, naming compound. So IUPAC nomenclature has to do with naming compounds. And it's also called IUPAC nomenclature for organic compounds and inorganic compounds. So what we are looking at is IUPAC nomenclature of organic compounds. Are you with me?
Yes.
Okay. If, for example, I have this, is this an organic compound? This one I draw the board.
No.
Okay, this is an inorganic compound. And this compound also has its own way, its own systematic way of naming it. Right?
Yes.
Okay. Can you remember what was the method of naming this compound? Which one do I name first?
And it's the method first. Sodium.
Okay. The pattern is 1, you name 1, 2, 3.
Yeah.
With the oxidation number of the third one attached to the ending in terms of their name. So this is like sodium triazocarbonate 4. Sodium triazocarbonate 4. The 4 is talking about you calculate the oxidation number of carbon and then add it to the name. Okay, so that is for organic compounds. But for organic compounds, organic compounds also have rules for naming them. I'm left with how many minutes? 8 minutes to go. I can't finish this. Let's see how far we can go. But once it's shut down, I will round up for today. Till another day.
Okay.
So IUPAC nomenclature, like I said, has rules for naming it. Nobody will ask the students mention the rules for naming organic compound. No, but they will be faced with they will be faced with questions such as give the IUPAC name of the compound, which means they are expected to know the rules for them to be able to name a compound. To let the student know the various rules, how they are applicable in naming compound. The first rule of naming organic compound is count the continuous longest carbon chain. That's rule number one.
Okay.
Count the continuous longest carbon chain and make that the parent name. Count the continuous longest carbon chain and make that the parent name. Are you done?
Yes.
Okay. Now let me draw something on the board so that I'll use it to explain that thing I just said now. Are you still what I'm? Are you seeing the board?
Yes, I can see.
Okay, so can you tell me how many carbon atoms can you see?
Okay, I can see 7.
Okay, let me explain it. You can see 7. Who's the other person there with us now? There's no name on it. I'm seeing S cover. I don't know who's S cover, please. But whoever is that person, how many carbon atoms can you see, please? Okay, Madam Esther, check again. How many carbon atoms can you count?
It's 8.
Okay, no longer 7 anymore.
No.
Okay, you counted 8. Okay, let me see how you arrive at the 8. Now we said we count the continuous carbon chain. Let's count. You can just count on this 1, 2, 3, 4, 5, 6. That is one counting. Let the student know 1.
Okay.
With me.
Okay.
That is one long chain, one counting. Again, count 1, 2, 3, 4, 5, 6. That's another counting again. 6. Then let's say again 1, 2, 3, 4, 5. That's another counting. So the longest I've counted now is how many carbon atoms? Is 6. So that is the longest continuous carbon chain. So my carbon chain, which I counted, is 6, which is going by this. Let me use this pattern. Prepare this one. This was the one I counted. To be 6. Right?
Yes.
Okay. So 6 carbon atom is what? What's the parent name for a 6 carbon atom? Remember I said mate. Mate is 1.
Yes.
So 6 is what?
It's heavy.
Yes.
X. Okay. X. Now again, looking at the structure that is on the board, they are all single bond. That is one line in between the carbon atom, right?
Okay.
Yes.
Good. That means it belongs to the homologous series known as XANE. So the name will end with ANE.
Okay.
So this is the parent name of this compound that I've drawn, XANE. So that is rule number 1. Count the continuous longest carbon chain and make it the parent's name, XANE. Are you with me?
Yes.
Yes.
Okay. Now, rule number 2, or whichever way you are putting it, it must not be 2. That's another rule, is that if there are substituents present, like I didn't count this one now. I wish I have another marker. I will have used a different marker to circle it. I didn't count this. I didn't count this as well. Right? Good. These 2 that I didn't count are known as what we call substituents. Now, the rule is that the substituent should be given the smallest possible number. Substituents should be given smallest possible number. And that way, And that number will determine the correct numbering. Because there's what we call correct numbering and wrong numbering. 3 minutes to go. Quickly, let me see how we can run this. I will move on, please.
Yeah.
Eh?
Yes.
Okay, now let's number this our carbon atom from this extreme end. This is 1, 2, 3, 4, 5, and 6. Then let's number from the top again. 1, 2, 3, 4, 5, and 6. Are you with me?
Yes.
Okay, so these two substituents that I circled, if I number from my extreme end, which is where my hand is now, going up like this is on carbon atom 3 and on carbon atom
5.
5. So I'll do 3 plus 5. 3 plus 5 will give me what?
8.
8. Let's leave that aside. Now, numbering from the top where my hand is now. This is on carbon atom 2, and this is on carbon atom what? Numbering from the
3.
top. This is 1,
3.
2, no, it's on 4. 1, 2, 3, 4. So I have 2
Okay. 4.
and
Yes.
4. 2 plus 4 will give me what? 6.
6.
So what's the smallest number between 6 and 8?
6.
6. So the correct numbering
Okay.
is following from where my hand is now, going like this. Because the smallest number is 6. Any question?
No.
Okay, so which means this CH3 is called methyl. So this is on carbon atom 2, which is 2-methyl. This again is on 4, which is called 4-methyl. How many minutes? Just a minute left. Okay, now another rule is that when we have substituents which are of the same substituent, use the word di for 2, tri for 3. This is methyl, methyl. How many methyl is that?
2.
2.
2. So by name now, this is called 2,4 dimethyl hexane. 2,4 tell me that I have a methyl on carbon atom 2, which is 2-methyl. I have another one on carbon atom 4. So I cannot be writing 2-methyl, 4-methyl hexane. No, it's like tautology. I'm repeating myself. So since they are methyl of the same thing, I'll use the word di, di. Then I'll use this number to tell me where the methyl are. 2, 4 means a methyl on carbon atom 2 and a methyl on carbon atom 4. Di means there are 2. Hexane tells me that the parent carbon atom is 6.